In this video, I'm going to look at sketch graphs. The particular type of graph I'm going to look at in this video is the hyperbola. So let's have a look at an example of sketching a hyperbola. The example we're going to look at is sketch the graph of y equals 1 over x minus 3. Now, when we're sketching any sketch graph, we always need to relate it back to the standard form of the curve. And the standard form of the hyperbola, we can think of it as being centered at the origin with a vertical asymptote along the y-axis and a horizontal asymptote along the x-axis. Now, looking at the graph of y equals 1 over x minus 3, we can think of this as being a translation 3 units to the right. Now, if we translate our standard hyperbola 3 units to the right, we know it will have asymptotes at x equals 3 and also at y equals 0, the x-axis. That asymptote won't change. Now, you might think to yourself, why has it moved 3 units to the right? Well, if we have a look at the equation itself, y equals 1 over x minus 3, you need to think to yourself what value of x is going to produce an asymptote here. And you can see that if you put in x equals positive 3 into the denominator of the fraction on the right hand side, x equals to positive 3, then that denominator becomes 0, and of course 1 over 0 provides our asymptote for us. So that's the reason it's moved to the right, which might seem counterintuitive to the negative 3 at the end of it. However, that's the reason we move it to the right. It's actually the value of x which produces 0 in the denominator. Having placed the curve with its asymptotes, then we need to calculate any intercepts if there are any. So it's always a good idea to write down the heading that we're going to calculate the intercepts. And to calculate the intercepts, we put firstly a y value of 0. Y equals 0 is an asymptote, so there won't be any x-intercept. But if we put x equal to 0, we get y equal to 1 over negative 3, which produces y equals 1/3 as an asymptote for us. So we can sketch the graph by firstly sketching in the asymptotes. Asymptote here will be the x-axis, vertical asymptote at x equals positive 3. And then label up all the significant points. The y-intercept at 0, negative 1/3, the vertical asymptote at x equals 3, and of course don't forget to label the x and y axes. Here in a second example, we're going to sketch the graph of y equals minus 12x plus 9 over 4x minus 1. Now, in order to sketch this graph, we firstly need to do a long division. Let's divide the numerator by the denominator and do a polynomial long division. So we need to divide minus 12x plus 9 by 4x minus 1. 4x goes into minus 12x minus 3 times. Multiplying back then gives us minus 12x plus 3. Do the subtraction, we have 6 as the remainder. So we can write minus 12x plus 9 over 4x minus 1 equals negative 3 plus 6 over 4x minus 1, the remainder. So again, relating it back to our standard hyperbola, we can think that the negative 3 is a translation 3 units downwards, and that we'll have a vertical asymptote somewhere when the denominator is equal to 0. So if we think of the denominator of 6 over 4x minus 1, when is that going to equal 0? So it'll have an asymptote when 4x minus 1 is equal to 0, or when x equals a quarter. There'll also be a horizontal asymptote at y equals negative 3. And now let's calculate our intercepts. Firstly, if we put y equal to 0, we get 0 equal to minus 12x plus 9 over 4x minus 1. Solving that gives us x equal to 3/4. The other intercept will occur when x is equal to 0. Solving that, we get y equals 9 over negative 1, or negative 9. And so these are our intercepts, and now we have everything we need in order to sketch our graph. So we sketch up the axes, label them, and label the significant points on the curve. Horizontal asymptote at negative 3, vertical asymptote at x equals positive 1/4, and a y-intercept at negative 9, x-intercept at 3/4.
For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.